Welcome to College Algebra, Section 3.3, Part 3. We just discovered that -3 was a root, so let's use that to simplify our polynomial with synthetic division. So my coefficients are 2, -3, -23, 12. So here we go. We know we do this right if we get a 0 down here, since we know that -3 is a 0. So 2, -3 times 2 is -6. -9. -3 times -9 is 27. Add those up to get 4. -3 times 4 is -12. And now you see why I put a smiley face there, because we finally got a 0. And that simplifies our polynomial tremendously. So -3 is a solution, as a root. So that's going to be, our new polynomial is 2x squared minus 9x plus 4. So that's a lot smaller. Now is equal to our new function. So we still have two roots that live in here, and so you might, now we used Descartes' rule of signs to limit our number of potential answers. By the way, it is possible that -3 could be an answer again, meaning it has a higher multiplicity, except that we know there's only one negative answer, so we're okay there. Now, if plugging in these numbers one at a time seemed like a long way to do it, there is another way to do it, and that's just to use synthetic division each time. So I could have done synthetic division 1, 2, 3, 4, 5 times and got 5 numbers here that weren't 0. And then finally, when I did -3, I would get 0. So if you like synthetic division a lot, do it that way. But let's go ahead and plug in a new number now. Like the next number I have is 4. Let's see if 4 works. 4 times 4 is 16, times 2 is 32. 9 times 4 is 36, so we have 32 minus 36 plus 4, and look at that. We're going to get another 0. So 4 is going to be our next solution, so let's put 4 here. I shouldn't say solution. If this was a 0, then it would be a solution. Really, they're roots. So here's my coefficients, 2, -9, 4, so let's do it. 4 times 2 is 8. -9 plus 8 is -1. 4 times -1 is -4, and I get a big 0. So we've now found a negative solution and a positive solution, and so that tells me that I'm going to get no imaginary solutions. This is the scenario we're going to have. We're going to have 2 positive, 1 negative, 0 complex, thanks to our method of discovery. So look at how easy our final equation is now. 2x minus 1 equals 0. That's how I got. That's our constant term. That's our x term. So it's 2x minus 1 equals 0, and now you can just solve this. Add 1, 2x equals 1. Divide by 2, divide by 2. X equals 1/2. So our three roots are, -3, 4, and 1/2. And you see that all of them are on our list of initial potential answers. Here's 1/2, here's -3, and here's 4. So now that we know that, we can factor this completely. That's what they were asking us to do. So f of x equals, and you just flip the signs, x plus 3 times x minus 4 times x minus 1/2. Now, that's correct. Another way you could have written this is, instead of x minus 1/2, you could have put 2x minus 1 there. So if you wanted to, you could have left that as 2x minus 1, and technically that's kind of factored right there. So that's just a matter of preference. If you want them to all be x plus or minus something, or if you just want to leave this last one as 2x minus 1, it's kind of up to you. If you were to FOIL this, you would get this. So that's how you could check your answer. I know that problem took a long time. It's a hard problem. But what's really cool is you can use this method to solve a polynomial of any number of terms. Using this method, you could solve a polynomial that had 100 terms, which basically means that we can solve any polynomial now of the form something x to the whatever, plus or minus something x to the whatever, plus or minus something x to whatever. You can solve almost any equation as long as there's no x's and exponents or something. That's pretty amazing, and you should give yourself a pat on the back for that. We're now going to solve this next one. I'm going to do it a lot faster without going in as much detail. You should actually try to pause the video and do it on your own if you can. So start by finding your potential solutions. Do Descartes' rule of signs. This is optional. You don't have to do this if you don't want to, but it can help you find the answers. Then use synthetic division. Then you're golden. So pause the video, see if you can get it, and hopefully you got the answer. So if not, you can just watch me do it. Our potential answers are all of the factors of 20, which are 1, 2, 4, 5, 10, 20, divided by 1, 2, 5, or 10. So we are going to get a lot of potential answers here. So here we go. Let's divide all of these by 1. So our potential answers are 1, 2, 4, 5, 10, and 20. Okay, let's see what fractions we get now. Let's divide all of these divided by 2. So first, so we've done 1. 1 divided by 2 is a half. That's new. 2 divided by 2 is 1, so we can skip that. 4 divided by 2 is 2, so skip that. 5 divided by 2, that's new. 10 divided by 2 is 5. 20 divided by 2 is 10, so that's 2 is good. Divided by 5. 1 divided by 5 is a fifth. 2 divided by 5 is 2/5. 4 divided by 5 is 4/5. 5 divided by 5 is 1, so that one's okay. 10 divided by 5 is 2. 20 divided by 5 is 4. So that rest of that's okay. Now let's do 10. 10 divided by 1 is 10, which is on our list. 10 divided by 2 is 5, which is on our list. 10 over 5 is 2, which is on our list. 10 over 10 is 1, which is on our list. And finally, 20. So 20 divided by 1 is 20. 20 divided by 2 is 10. 20 divided by 5 is 4. 20 over 10, I mean, is 2. So there we go. There's all of our potential answers right there. There will be a question potentially on the test of what are the potential answers. So you do need to know how to go through that process I just did. I did all of these divided by all of these one at a time. 1 divided by all of these, 2 divided by all of these, 4 divided by all of these, 5 over all of them, 10 over all of them, 20 over all of them. So it just takes a while, but just work through it and you will get it. Next, let's do Descartes' rule of signs to find out what our answers are going to look like. So how many sign changes do we have? All right, so I'm just writing my little Descartes table. There's a sign change, there's a sign change, no sign change. So I have 2 positive potential answers. That pretty much tells you we're going to get 1 negative answer because we have to add up to having 3 total answers. So, but just for the heck of it, if I plugged in a negative here, this would become negative. Negative here would get squared, so that would stay whatever this is, which is negative. This right here would be negative, and then a plus. So no sign change, no sign change, 1 sign change. So it's going to be the same as last time. We're either going to have 2 positive, 1 negative, and 0 complex, or 0 positive, 1 negative, and 2 complex. So those are our potentials. All right, now you know the game. We are going to use synthetic. We're just going to plug them in one at a time to see if we can find an answer. And unfortunately, sometimes this just takes a while. So, but I'm going to sit here and do them. I like to start with 1 because it's easier. So if I plugged in 1, I'd get 10 minus 63 plus 87 plus 20. Nope, 1's not going to work. Before I try -1, I'm going to try +2 because that's pretty easy. 2 times 2 times 2 is 8. 8 times 10 is 80. 2 times 2 is 4. I'm going to write 80. 2 times 2 is 4, so what's 4 times 63? Whoops. 4 times 63 is 252, so that'll be minus 252 plus 87 times 4 is 348 plus 20, and it's pretty easy to see that that's going to be a positive number. So 2 doesn't work. Let's try 4. 4 times 4 times 4 is 64, so that's going to be 640. Minus 4 times 4 is 16, so 16 times 63 is 1008. Plus 87 times 4 is 348 plus 20. Okay, so here we go. 640 minus 1008 plus 348 plus 20. Oh, and look at that. We get an answer. So positive 4 is going to be an answer, which tells me that because I just found a positive answer, this scenario is not happening. We're going to get 2 positives, 1 negative, and 0 complex. So I'm over 10 minutes, and so in part 4, we found our root, so we're over the hill. Now it's all downhill from here. So I will see you in part 4.